Okay, guys. Shh. Okay, we're gonna get started. So this is the last part of exponents, right? Of understanding exponents. I'm looking forward to being done with these so we can move forward. But now that you know them a little better, I just feel like I should keep going so that you're using the same tools again tonight. It's just that with division, we're talking about fractions, right? Because every fraction is a division problem, right? It's the numerator divided by the denominator, right? So that's what we're going to talk about real quickly. And first of all, remember, I'm in essence really teaching you shortcuts, right? I'm going to first do it the long way so you can see it the long way. And then I'm going to show you the shortcut method, right? So the long way, let's say I gave you x to the 6 over x to the 4th, right? If I did that the long way, it would be x times x times x times x times x times x upstairs, right? 1, 2, 3, 4, 5, 6. There's 6 of them. Downstairs, it would be 4 of them. X times x times x times x. Right? You with me? That is the same thing as this, right? What is x over x? 1. So I could cross that out, right? Oh, but wait, what's x over x?
1.
Oh, but I could cross that out. Oh, but what's x over x? 1. Oh, I could cross that out. Oh, but what's x over x?
1. Whoa.
Right. So what do I have left?
No. Just 2x.
Just x squared, right? X squared on top with a 1 down below, so all I need is the x squared. Right? You with me? You with me? So that's the long way. And it's easy if you do it. If you write it out the long way, it's really easy. The problem is it takes forever. Yes, Isabella.
So is it like subtraction?
Exactly. So notice what this would be. It could be 6 minus 4, right? So it could be 6 minus 4. So I like to think of this fraction line right here as a huge minus sign. See that long minus sign right there? So it's 6 minus 4. You with me? So this is the shortcut method. X to the 6 over x to the 4 is equal to x to the 6 minus 4. Okay? So the actual formula that you will see is this. Let me think here. What am I doing? Yeah. Okay. X to the m over x to the n is equal to x to the m minus n. Okay? So that's your formula that we're basically using when we do these. Now notice something that's really important to understand, because on the easy ones, it's not an issue. As they get a little more complicated, it becomes an issue. Notice this. X, well, I'll just use this one. What's the final answer? It's going to be x squared, right?
X is 2.
Right. Is this a numerator or a denominator or what?
It's a numerator. It's a numeral.
Well, it's not a fraction, is it?
Oh.
But if I made it a fraction, how would I make it a fraction?
It's x over 1, right?
It would be, right? You guys listening? Yeah. This is important. This is important. Really, this is the time to be quiet and just listen, right? Or participate, but don't talk to your neighbors. X squared over 1. X squared is now the numerator, am I right? Yes? Yeah. It's upstairs. Yes? You get that? So when I do this little trick, x to the 6 minus 4, my final answer is an upstairs answer. It's a numerator answer. Now, even if it's not a fraction, I think of it as an upstairs, as a numerator. Does that make sense? You'll see why in a minute. You'll see why in a minute. Let's just do a few more of these first and just try them. We'll just make sure we're good. So that was number 1. Let's do number 2. How about x to the 12th over x to the 5th? What would it be? X to the 12 minus 5 which is x to the 7. Yes? Pretty straightforward, right? This x to the 7, is that a numerator or a denominator? Would that eventually, I mean, if I were to put that into a fraction, it would be in the numerator, right? Okay, good. All right, what if I gave you this one, number 3? X to the 3rd over x to the 9. I now have x to the 3 minus 9, which is what?
-6.
X to the -6, which is what?
1 over x to the 6th.
All right, 1 over x to the 6. Because we knew that was in the numerator, so we just brought it down to the denominator, right? That make sense? Okay, good. Because you cannot leave your final answer with a negative exponent. Everybody's totally with me, right? Just the 5, you got it? Okay. All right. Now, what if I gave you something like this? What if I gave you 2/3 x to the 4th over x squared? What would I do now?
The 2 and the 3 would go together, and so would the x to the 4th and the x to the 7th.
Yeah. So always, and when I do these, I always take care of the numbers, the coefficients first. Can I simplify that?
Yeah.
2/3. Can I simplify 2/3? Is there a number that goes into 2 and 3 that I could reduce it to? No. So I immediately put an equal sign, and I do a 2/3, and I make my fraction line a little bit longer, right? So immediately I've taken care of that. Now all I have to do is this, which you already know how to do, right? That's so easy. You've taken care of your 2/3, right? It's a piece of cake now. You've already written it there. Now the question is, what do? I get x to the 4 minus 2, right? That, where does that go? Upstairs or downstairs?
Upstairs.
Upstairs. X to the 4 minus 2, which is 2. Am I right? There's your final answer. Does that make sense? When I did the x to the 4 minus 2, I had to put it upstairs because I had a fraction with the coefficients. Does that make sense? So now let's try another one. 5. What if I gave you 4x to the 9th over 16x to the 6th? All right, what would I do first? Okay, Bob.
You take care of the numbers, and so 4 goes into 16 easily.
Okay, so 4 goes into 4 once, 4 goes into 16 4 times. So immediately I write that 1/4.
Yep.
Immediately 1/4 with a long fraction line. You with me?
Yeah.
And now I say I have x to the 9 minus 6.
And so it's x to the 3rd.
X, and it goes upstairs, right? X to the 9 minus 6 is 3. X to the 3rd. And that's you can either keep the answer like that, or you could rewrite it. That's fine. Or you could rewrite it as x cubed over 4. You don't need the 1 in front of it, but you can. It doesn't matter. Okay? Number 6, sorry. What if I gave you this? What if I gave you 5x to the 4th over 20x to the 9th? What would I do? Okay, Harrison.
5 becomes a 1, the 20 becomes a 4.
Okay, 5 goes 5 once, 5 goes into 24 times. Immediately I go 1/4 with a long fraction line, right?
Mm-hmm.
Okay, and now keep going, Harrison.
And then the x go together, so the x goes up top, and it's 9 minus 4, which is 5.
Wait,
It's negative. Or,
it's 4
4
minus 9.
So it's negative 5.
X to the negative 5. Now, Harrison, what do I have to still do?
You have to make the x go downstairs, so that means that it's 1 over 4x to the 5th.
Beautiful. Does that make sense to you guys?
Mm-hmm.
All right. Let me just look at my homework and make sure I'm throwing everything at you that I'm going to throw at you. Boom, boom, boom. Okay. So that's 6. All right. Now let's run to 7. What time is it? Oh, great. You're going to have lots of time to work on homework today. All right, but 7. All right, here we go. 7. What if I gave you something like this? X to the 5th, y to the 6th over x to the 9th, y squared. What would I do? I'm going to do the same thing. I'm going to draw my fraction line first, though. Okay? And I'm going to deal with my x's first. It's x to the 5 minus 9. You with me? X to the 5 minus 9, that goes upstairs. X to the 5 minus 9, that's negative 4. You with me?
Yeah.
And then, now I've got y to the 6 minus 2. So that's y squared, right? I mean, y to the 4th, sorry. Y to the 4th. And this
Well,
is
it did y to the second over x to the 4th.
but notice there's nothing down here, right?
So that means I have to bring the x downstairs.
But yes, we're going to bring this down. So it's going to be y to the 4th over x to the 4th. Got it? Make sense? All right. All right. Let's make it slightly harder by putting numbers in here. What if I had 3x squared y cubed over 6x to the 5th y? What would I do?
You've got to combine everything.
All right, but one thing at a time. Always take care of the coefficients first.
So you can turn into
So
1 over
3
2.
goes into itself once, and then 3 goes into 6 twice.
Right, exactly. So immediately I write my 1/2, okay? And then, with a long fraction line, x to the 2 minus 5. X to the 2 minus 5 is x to the negative 3, am I right?
Yeah.
And then y to the 3 minus
1. Because there's an imaginary 1.
right, there's an imaginary 1 there. 3 minus 1, which is 2. Y squared. So my final answer is what? I'm going to bring this.
2x to the 3rd. Wait, it's y to the 2nd.
Yes.
1 y to the 2nd over 2x to the 3rd.
Yes. Right? Does that make sense? See what I did?
Yeah.
Okay. Now, what if I gave you something like this? We're almost done. We got just like 2 or 3 more ones to do. What if I gave you this? X squared over y cubed raised to the 5th power. That 5 is next to what?
Next to the parentheses.
It's next to the parentheses. And parentheses always mean multiply. So I'm going to multiply the 5 times every exponent inside that parenthesis.
Oh, so it's x to the 10th.
So it's x to the 10th
Over y to the 15th.
y to the 15th. Exactly. Does that make sense?
Yeah.
Oh,
That
you
only gets multiplied times the exponent, right? All right, so now let me come over here. Just I like writing higher up. 9, 10. Here we go, 10. How about this? How about I did 2x to the 4th over 4y squared cubed. What would I do first? Simplify coefficients. PEMDAS says do what's inside. Whatever you can do inside the parentheses first. 2 goes into 2 once. 2 goes into 4 twice. So suddenly that gives me 1x to the 4th, or just x to the 4th, over 2y squared. You with me? And then I'm going to cube it. So now, what is the 3 next to? Parentheses. Parentheses always means multiply. So I have to multiply that 3 times every exponent. Only exponent, not a base. Only the exponent. Here's a base, there's the exponent. Here's a base, there's the exponent. Here's a base. What's the exponent on this?
Oh, it's 1. So
it's a 1. Right, so suddenly it's going to be x to the 12th over 2 to the 1 times 3, 2 cubed
Y to the 6.
y to the 6. And you can leave it like that. I'm okay with that. Or you could rewrite it as x to the 12 over 8 y to the 6.
I guess I'll just leave that as 2.
That's fine. I'm okay with that. All right, last big concept that you have to understand. It's weird, but it's a great shortcut. I could do the long way to prove it to you, but I think you're going to find the shortcut so easy, you're going to just be fine with it. If I gave you x over y raised to the negative 1 power, you with me?
Yeah.
Blaze, you watching? Whenever you have a fraction raised to a negative power, to change that power positive, all you have to do is
Switch it.
flip the fraction. So it's now suddenly y over x to the positive 1, which is just y over x. Right? So let's do one more with like this so we can just see it. So let's say I gave you 2x squared over 8y to the 5th. All right, and we're going to raise it to the negative 3. That's fine. So what do? I'm going to first flip it, right?
You can.
Well, actually, first let's do this.
Let's do that, yeah.
Let's do this. 2 goes into 2 once, 2 goes into 8 4 times, right? So suddenly, but now I'm going to flip it. Okay? So I've got
4y
4y to the 5th over x squared, and this is all in parentheses, but now now it's raised to the positive 3. You with me? So now I have the 3 is next to the parenthesis. Parenthesis means multiply. I got to multiply that 3 times every exponent.
So you do 4 to the 3rd,
Yes.
4 cubed,
Right.
and y to
So it's going to be 4 cubed
y to the 15th,
y to the 15th
x to the 6th.
over x to the 6th. Does that make sense?
Yeah.
Awesome. You guys are ready for the homework. Okay. All right. So let me just turn this off.